Howdy everyone, Mr. Causey here with another chemistry lesson, and today we're going to talk about concentration and molarity. That's molar concentration. So let's get started. In this lesson, you're going to learn about concentration, molarity, dilution, how to make dilutions, and much, much more. You'll need, as usual, your periodic table. You'll need a calculator, so be sure to get fresh batteries out there and get your calculator ready. And you must know what a solution is. You must know Avogadro's number in the mole. And you must know how to find molar mass. So are you ready? Let's get started. Many chemical reactions occur in solution. And so because they occur in solution, we need to learn a few things. We need to understand concentration, and we need to understand dilution, and we need to understand solutions. So let's take a look at solutions. Solutions are homogeneous mixtures that consist of a solute and a solvent. The solute is the substance dissolved, kind of like if you're making Kool-Aid, it's the Kool-Aid and the sugar, and the solvent does the dissolving, which is usually, or many times, water. And remember, water is the universal solvent. It dissolves more things than anything else. So, concentration is the ratio of the amount of solute to the amount of solution or solvent. So it's solute per solution or solvent. And remember that if you add more solute, you're going to increase that concentration. If you add more solvent, you're going to decrease the concentration. Dilution. Dilution is increasing the amount of solvent. So if you put more solvent in, you're going to decrease the concentration. And that's a common way to take a stock solution and make other solutions. But these are all kind of qualitative terms, and scientists want quantitative terms. Scientists want terms that can be measured with numbers and mathematics. So they've come up with molarity. They've also come up with another idea called molality. But molarity is the moles of solute per liter of solution. Now notice I said solution, not solvent. So you measure out your solute and then you add the solution, the solvent, until you have the amount of solution you want. And there are specialized flasks that we use to do that with. So molarity, which is a capital M, and it's the moles of solute per liters of solution. This gives us a good quantitative way of calculating things. So let's look at an example. Calculate the molarity of a solution prepared by dissolving 16.75 grams of ammonium nitrate in water to make 275 moles of solution. All right, well, let's look here. First, we have our grams, and we have to change that to moles. And then we're going to have to take our milliliters and change that to liters, because it's going to be moles per liters. So we want to make sure that we make the proper conversions here. So to the blackboard, the molar mass of ammonium nitrate, well, there's two nitrogens. Note right there, two nitrogens. And that's going to give us 2 times 14.01, which is 28.02 grams of nitrogen. We have 4 moles of hydrogen, and that's going to give us 4.032. So we just do our mathematics. And oxygen, of course, is going to be 3 of those. There it is right there, 3 oxygen times 16.00 equals 48.00 grams. Now remember, I get all these numbers off of the periodic table. That's why we need to have it handy. So there's our grams per mole, or our molar mass. Now, let's go and figure out the moles. If I know the molar mass, all I have to do is take my grams, multiply it by the molar mass. Now you notice that we flipped it over because we want grams to cancel out. But now that's going to give us 16.75 times 1 divided by 80.05. And if we plug and chug that, that gives us 0.2092 moles of ammonium nitrate. So plug and chug that, and you should have it. So for the molarity, we take our moles, divided by the solution. And we're going to change, now remember we have to change our milliliters to liters. And so there it crosses out. And I get moles per liter, and that's molarity. 0.7607 molar ammonium nitrate. All right. How do we make dilutions? Well, to make dilutions, we take a stock solution that's usually of a high molar concentration, and we just dilute it by adding solvent. But in order to do that, we need to be sure we understand how many moles are in that molar concentration as we add our solvent. So let's look and see here how we can put this together. I have a little example here to show you how we're going to make solutions and or how we're going to make dilutions. Let's say we have two samples here. We have our stock solution right here, M sub 1, of some molarity of high concentration, and we are going to dilute it into M sub 2, a lower concentration. But how can we do that? Well, a little algebra and mathematics can help us come up with a little equation. We know that the molarity of M sub 1 has to be the moles divided by the volume, and the molarity of M sub 2 has to be moles divided by volume. Now, the interesting thing about this is that the molarity is going to change because we add a solvent, not the solute. The solute is going to remain the same. The number of moles per sample is not going to change. The solvent is going to change. So what we can do is rewrite this with a little algebra. Notice how we rewrote that. And then realize that the moles of the solute don't change, so they're equal. Mole sub 1 equals mole sub 2. And just like in geometry, if two things are equal to the same thing, then they are equal to each other. And M sub 1 times V sub 1 equals M sub 2 times V sub 2, which basically tells us that the molarity of the first solution times the volume of the first solution equals the molarity of the second solution times the volume of the second solution. And this allows us to calculate new dilutions. So let's look at an example. How would you prepare 3 liters of 0.5 molar H2SO4, sulfuric acid, from concentrated 18 molar sulfuric acid? Well, 3 liters would be my new volume or my final volume. The molarity, 0.500 molar, would be my final molarity. And 18 molar is my initial molarity. And I just need to find out what is the amount of water I have to add to that in order to get the new or final molarity. So, to the blackboard. Here's my equation. With a little algebra, we change it to initial volume equals. And this is going to tell me how much water I need to add. All right, so we got V sub 1 equals 0.500 mole times 3 liters divided by 18.0 molar. Check all our numbers there, and we'll see that if we plug and chug that, we get 0.0833 liters with 3 sig figs. That means if I take 83.3 milliliters and add water to make 3 liters, ta-da, I get what I need. All right, recap. We looked at solutions. We looked at concentration and dilution. We looked at molarity, and we did examples of how to make a dilution. The number one thing to molarity is practice. You need to practice changing grams to moles, and then taking your moles and dividing it by the volume. And remember, it's volume of solution, and that's going to give you your molarity. Practice is the number one thing. So, if you have any questions, be sure to just shoot off an email to Mr. Causey at mrcausey.com. Be sure to check out Mr. Causey's World. I have PowerPoint videos there, and of course, you can see those videos on YouTube as well. Happy ions, everybody.